field. This is conjugate field. No, this first term is conjugate field. So you do the same thing. At the end, you get 8 terms. Okay, and later on, then only we apply the symmetry because there are terms are the same. So for example, these two terms, they are exactly the same. It's just the different position of the x. But when you do your measurements, you cannot differentiate the position of the complex field, no, the position of the conjugate field and the complex field, because the complex field is in front here, the complex field here is in the middle. Your measurement, we cannot identify the position of this. They must be the same. So these two terms are the same. There's one more term is the same, and also these terms are the same. All right. So later on, then only I will do this. Okay. So now we can substitute inside the equation of motion. This is what I have done last week. Okay. So I want to redo this. So, okay. Okay. So I make it a curly bracket. I make all this that I want to substitute curly bracket. Okay. Do we still have time? Okay. Rushing. Okay. So our P, okay. Usually we try to do first order first. We try to do the linear first, and then second order, and then third order. Because the power series expansion, because why the series expansion, the perturbation, series expansion or perturbation is the same. Why the method is so popular? Because of we can do it level by level. We can do the first level, and then we do the second level. Second level depends on the first level that we have already solved. And then after this, we do the third level, the third order. The third order depends on the first and second order that we have already solved. So it is that's why this method is very popular. So now I substitute the linear first. Okay, I substitute the linear P1. So I substitute the linear first, the P1 for P. So I paste here, I paste here, I paste here. So this term is not relevant because this is P to power of 3. Okay, you can see that left and right, the strength of the field is just 1. Okay, the left hand side, this is 1. If I substitute this P1 to power of 3 here, you see every field you have the triple field. So when we can substitute, no problem, but after this we want to balance, we want to collect the terms with the same order. This one become irrelevant. Okay, are you still with me? Okay, yeah. So now this term is irrelevant because this term is nonlinear. So after the substitution, we can find our chi ix. So when we work it out, you can see that because these are conjugate, no, these are complex and complex. This the right term is conjugate, and conjugate, the same as this is complex, this is conjugate. So we need only to consider the complex, we ignore the conjugate. Because once we solve the complex, the conjugate we can find by applying the complex conjugation. Are you still with me? Okay, yeah, you can remember. Okay, now for the first term, we take the time derivative, we have minus omega squared. So we can delete this. Okay, so for the first term, so this is what I have showed to you last week. So for the first term, after I taking the time derivative of this, I ignore the conjugate. So I have minus omega squared. the second term, I take the first order time derivative of this. I have this minus I omega and multiply with everything. And the third term, I do not do anything because there's no time derivative. And I consider only this for the right side for the field. So as I said, you can cancel all the half, right? Because every term left and right got half, you cancel. Every term left and right, you have this E field, you cancel. Right? You cancel. Every term got this exponent minus I omega t, you cancel. So at the end, because the right hand side, you don't have the chi. So after you cancel all this term become 1. So it's like this. The left hand side, you have this. So every term of the left hand side, you got the chi 1. So I factor out the chi 1 and epsilon 1. All right, so you have this. So you solve your chi 1. So this is the response that we are interested. Okay, so the chi 2 is the same thing. Okay, so for the second order, so I copy paste this again. Okay, so when I copy paste for the second order, you have to be very careful. The second order, I will let you do it. Okay, so all the first order, we delete. I delete all the first order because first order already considered, you do not do it anymore. The right hand side is 0. Are you okay? Why I said the field is 0? Because now I want to do the second order. Because the right side is the field that we apply, always the first order. It's a strong field, but we already do it, we have already considered in the first order. Okay, so now we substitute the P2. The P2 like this. Copy and okay. So this one, the chi is soft just now. I yellow it. Okay, so now is second order. Second order. Okay, this one actually is P to the power of 3. So this is actually third order. It's not relevant. So we substitute into here. We substitute into here. We substitute into here. Into here. All right. So this one is not relevant, but just leave it here. So the second order, you can see that the right side got 0. You can see that there is no first order. Okay, actually there's first order here, but the thing is, when we expand this pi, you can see that these fields are all triple field. Okay, all are triple field. Okay. So you can see when you have to collect the terms with the same powers of E field. Okay, and you can see that all these field are two field. Okay, so when you solve like this, there's no the chi 1 actually is here, but the field are not matched. So when you solve all this, the chi 2 are all 0. Okay, because I think at the beginning I have already assumed that our system has inversion symmetry. We consider very simple system. So the chi 2 are all 0 because the right side is 0. Okay, now so that the second order is 0, then you no need to do anything. So I copy paste this again for the third order. Third order you have to do. I will substitute, but I let you do it. So I want to do the third order. Where is it? Copy the wrong terms. Let me see. Okay, so I should copy